Welcome to our new unit on sequences and series. We'll start off by going over some basic definitions so that you will know what we're talking about as we move throughout the lesson. Sequence is a list of numbers in a specific order, which can be described by a pattern. Series is a sum of a sequence. So basically we're taking the numbers and we're adding them up. So that's a sequence and this is a series. Term, that's going to be each number in a sequence, and the term number is represented by the letter N. This here is called sigma notation, and so when you see this, it means find the sum. They're going to tell you where to start, the bottom, and they're going to tell you where to end at the top. This is called sigma notation. There are two types of sequences we will be talking about: arithmetic sequence, a sequence in which each term after the first you're finding by adding the previous term. We call this a common difference. Geometric sequences. This is a sequence in which each term after the first is found by multiplying. This is going to be called common ratio. So how do you find the common difference? You'll take any term in the sequence and just subtract the term before it. And that'll tell you what the pattern is, the common difference. How do you find the common ratio? You take any term and you divide it by the previous term. This is how you find the common ratio. Here's the notation for any term minus the term before it. Here's the notation for the common ratio, any term divided by the term before. All right, so again, we're talking about arithmetic sequences. You will be provided what we call a general equation, C right here. Here's our first example. You are given a sequence, 5, 8, 11, 14, 17, and so forth and so on. What we need to do is we need to find the common difference and the first term in the sequence. The very first term listed in the sequence is 5, so we just go ahead and jot that down. In order to find the common difference, we take any term and subtract the term before it. So I will take 8 and subtract the term before it, which is 5. So my common difference is 3. I'm going to place that in my general term equation. 5 plus n minus 1 times 3. I'm going to use the distributive property, and then I'm going to simplify, and I have a general rule for this particular sequence. So now what I can do is I can find the 10th term in the sequence. So there's a couple of ways I could find the 10th term. I could set up a little table or chart, and I can go through the first time through is 5. Add 3 is 8. Add 3 is 11. And I can keep going and going and going and going to find out that the 10th term is 32. But the good thing about writing a general term for this particular sequence is that I could just plug in the term that I'm looking for, and voila, I'm done. Geometric sequences. Here's a review of what we said a geometric sequence is. Here's an example, 3, 6, 12, 24, and 48. Our general term equation for geometric sequence is listed here. For this particular sequence, a sub 1 is the very first term listed. In this case, it is 3. In order to find the common ratio, we're going to take any term and divide it by the previous term. So we're going to take 6 and divide it by the term right before it, which is 3. And 6 over 3 gives us 2. We're going to go ahead and put that into our general term equation. First, we start with the very first term in the sequence, which is 3. We write down our R, which is our common ratio, which is 2, and we raise it to the n minus 1 power. We could always go with a table or a chart and plot in every term multiplied by 2, multiplied by 2, and continue the pattern. However, once we write a general rule, we can plug it in, and we can also plug it into the calculator. And we get 1536. We're going to talk about two types of series. We're going to talk about the arithmetic series So here we're adding 5 plus 8 plus 11 plus 14 plus 17 plus dot dot dot. That means we keep going. There's no ending. So in the notation, you see we start at our first term and we go to infinity because there's no ending. So our function is 3n plus 2. And what we're going to do is we are going to use the formula just to find the first 10 terms. So first time through, we'll let n equals 1, and we'll keep going until we get to n is equal to 10. Take a look at the geometric series, 3, 6, 12, 24, and 48, plus so forth and so on. Here is our rule that we found, and we're going to put it in sigma notation, which means we're adding each continuing value. Here is our given equation, and we're going to find the sum of the first 10 terms. So we could continue with the pattern, which could be long, or we can use our formula that's given. This is n over 2 times the first term plus the last term. This gives us the same value of 185. Take a look. We could continue with the pattern until we get to 10 terms. Go back and add each one up and get a total of 3,069. We could plug it into our general rule, and here when we do that, we get the same thing, 3,069. Types of series, arithmetic versus geometric. The great thing about it, you will be provided these general formulas. Here's some practice problems that we are going to do. We're going to start off by determining if a sequence is arithmetic or geometric or neither. When I go from 40 to 43 to 46 to 49, see that we're adding plus 3 to each one, so that tells me there's a common difference. Anytime I have a common difference, it is arithmetic. When I take a look at my next sequence, negative 4, 12, negative 36, 108, negative 324, so forth and so on. Well, it doesn't look like the same number is being added, so let me try multiplication. Let me take one term and divide it by the previous term, and I keep getting negative 3. So my common ratio is negative 3. That would make this geometric. I look at the last one is 4, 16, 36, 64, 100. Sort of look like perfect squares. Guess what? It's neither. So 4 through 6, we're going to try to figure out what they're even asking us for. Find the two arithmetic means between 10 and 70. Arithmetic means between 10 and 70. What you think? 30 and 50 sound okay? Well, after we find our choices, we'll go back and we'll take a look at each one. What's the value of sigma notation? That means the sum of 3n minus 6 from 1 to 5. What do you think? 15. How did we get that? We'll come back and revisit it. Number 6. Which sequence is geometric? All right, time for some explanations. Here, arithmetic means there's a common difference. So we're trying to figure out what the common difference is. And so if we put 30 and 50 in there, we find out the common difference is 20. So 10 plus 20 is 30, 30 plus 20 is 50, and 50 plus 20 is 70. Nice. Take a look here. So we start at 1 and go to 5. So the first time through, we plug in 1, see what we get out of the function. We continue up to 5, and we add all those numbers together, and we get 15. When we check out each of our choices in number 6, we can see that the common difference in A is 5. We keep adding 5. When I take a look at D, we're subtracting 2. So those two are arithmetic. When I look at B and I take a term and divide it by the previous term, I get R is equal to negative 2. So that's why it's B. All right, last but not least, here's some problems. You are going to show work or provide an explanation for the answer choice chosen for each question. So what does that mean? Oh, it means you will be provided the answers, and you will work it out. Here we go, we're back. There is a key called math on your calculator. Try it, math, summation. See if you can put that in. Take a look at this one. Here's the explanation. 3 times 2 times 3, that would give you B. 8, take a look. The common difference is 4, which would make that 1D. Take a look at number 11, number 12.